Myself Naveen, I am associated with Testprepkart. So in this session, we are going to talk about NEET Physics. Right. So I hope you must be knowing that physics is a concept-based subject. So whenever we prepare for any sort of competitive exam, then first of all we must have very much clarity about the concepts. And number two, we must have sufficient amount of practice so that we can apply these concepts for problem solving. Right. So if we look at NEET paper pattern, so there are actually three levels of questions. Okay, like 35% questions are very simple question, or you can say these questions are very direct. You can simply, if you remember the definition and formula, you can directly answer. And 35% questions are moderate difficulty questions. In that, you just need to apply some sort of reasoning and some mix of two concepts and you will get answer. And 30% questions are higher difficulty level questions. So, most of the students who having general preparation for NEET, they are easily able to solve these 70% questions. Okay, but as far as rank is concerned, right, so these 30% questions are very important. These are the deciding factors, right? So when we prepare, then we must take care of this sort of questions, right? So in this session, we are going to discuss a very elementary concept and very important concept of NEET Physics, that is of grade 12th level. Okay, and first we discuss some of the fundamentals of that topic. After that, we try to see all difficulty level questions based on that concept, right? Okay, so let's start with the first topic, that is capacitor. So I hope you must be aware about this. So can you please tell me what is capacitor?
It has to do with electricity.
Right, right.
And balancing, like the voltage.
Yeah. Right, okay. So look, basically we can define that capacitors are energy storing element.
Okay.
And these elements can store energy due to potential difference and in form of charge. So whenever we apply some potential difference across a capacitor, then due to that potential difference, it stores electrical energy in form of charge, right? So if we have suppose any isolated capacitor and we are applying a potential difference V across this capacitor, then due to this potential difference, this body of capacitor is going to acquire some amount of charge. Let's say charge is Q. So it has been practically observed that whatever charge is stored in this capacitor will be proportional to the voltage or potential applied across this capacitor, right? So you can see there is a proportional relationship. So whenever we try to convert this relation in form of an equation, then we must put some constant over there. So in this case, we use constant C. This term C is known as capacitance of the capacitor. Okay. So basically, capacitance represents capacity of a capacitor to store charge. That how much charge this particular device or element can store is determined by its capacitance. The unit for measurement of this quantity is farad. Okay.
How do you spell that?
Yeah, F-A-R-A-D, farad.
Okay.
Right. Now please see, let's do a quick question on this and then we go for next concept. Suppose we have a capacitor of capacitance 2 microfarads, right? And it is subjected to 20 volts potential. So find charge accumulated on this capacitor.
40.
40, right. So we can simply write Q equals to CV, and it is a direct question, that is 2 into 10 to power minus 6 multiplied by 20. So from here we'll get 40 into 10 to power minus 6. So it should be 40 microfarad. Right. Now please see, if we have a conducting sphere, this conducting sphere having radius r, and suppose there are charge q on this sphere. Now we have to calculate its capacitance, right? So as you know, the formula of capacitor is, charge stored on a capacitor is q equals to c into v, right? Now here is a conducting sphere, this sphere having charge q and radius r. Can you help me to find capacitance of this particular conducting sphere?
You have to divide the Q by the V.
Q by the V, right, right. So this step is very clear, that whenever we have to calculate the capacitance of this capacitor, then we need to perform Q over V, right? But now the question is how to calculate V of this capacitor. So if you have a conducting sphere of charge Q and radius R, can you please tell me what will be the potential across this sphere?
Will it be the what do you call it? The area of the radius?
No.
I mean, area of the...
No. Please see. The expression for potential of a sphere, if this sphere having charge Q, it can be written as KQ over R, right? And where K is 1 over 4 pi epsilon naught, right? So from here it is a standard equation, right? So the potential will be 1 over 4 pi epsilon naught Q over R. Now if you substitute in this equation, then let's see, we are going to get a very interesting result, that is C equals to Q over Q divided by 4 pi epsilon naught into R, right? So from here we get the capacitance of this conducting sphere is 4 pi epsilon naught into R. Please look at this calculation carefully and let me know whether you understood or not.
Yeah, I understood.
Right. Now please see, we are not getting in details of this. Let's try to explore the properties of simplest form of capacitor. Okay, and then we do some questions based on that. The easiest version of a capacitor is called parallel plate capacitor. So what we do, if we have to design a parallel plate capacitor, then we take two conducting plates. It means these are metal pieces of equal area and we place them at some distance. So let's assume area of this plate is A and the separation between these two plates is D, right?
Okay.
Now we are applying some voltage across these plates. So whenever we connect some potential across any conducting material, then some current start passing through it. Right or not? Okay. And current is rate of flow of charge. So due to this process, some charge will start accumulating on this plate. Like this. Let's say plus Q charge is there. And I hope you must be knowing that if there are two metallic plates and we induce some charge on one plate, then due to that charge, opposite charge appears on second plate. Right? So on this plate there will be charge minus Q. Now please tell me, do you know how to calculate electric field due to a conducting plate or a plate having charge?
Electric field due to conducting plate.
Yeah, suppose you have a plate having charge density sigma, right? Sigma means charge per unit area, okay? And you want to calculate electric field due to this plate at any point.
We'd have to use the current and the density of the plate.
Okay. Okay.
Like divide them.
Okay. Okay. So first please tell me, have you studied electrostatics yet or not?
So the thing is, for me, I was doing my 11th grade, but partway through doing it, we had to move here.
Okay.
To the US. And according to the state requirements to where I live, I couldn't choose any science subjects other than anatomy.
Okay. Right.
Yeah.
Okay. So let me switch the topic. Right. Just wait for 1 minute. Let me upload a file for grade 11th physics. Then we shall discuss the concept of grade 11th. And then we try to solve some question on that. Is it fine with you?
Yeah.
Okay.
So I was just starting out my 11th grade, and then we had to move here. So
Right. So let me take the very basic topic of grade 11th. Okay, just wait for a second. Right. Okay. So now please tell me, let's switch the topic. Can you please tell me, do you aware about motion?
I remember something.
Right. It's fine. So
Because it has been over a year.
no
since I
problem.
did study
No problem. Let's try to explore the concept together. Don't worry about that. Okay. So let's try to define motion. Okay. So according to you, what is motion?
the movement of an object a certain distance.
Right. So what we can say, that we have to be more specific. So we can say if any object changes its position with respect to time, then we call it motion. Right? So motion is nothing, just change in position. Now please see, whenever we have to understand motion of an object, then there are certain factors which we need to take care. And you must have studied these concepts in grade 9th also. That first factor is distance and second one is displacement. Okay. So can you tell me something about distance and displacement?
So distance is just moving from one place to another.
Right.
And displacement is the same as distance but except in a certain direction.
Right. Okay. So we can say that distance means the total path length. How much total distance you have covered to reach a destination from the source is called distance, right? Total path length. On the other hand, displacement is shortest distance. This is shortest distance between source and destination. Okay. So let's try to understand with the help of an example. Suppose we are starting from point A, right? And we want to reach at point B, which is at a distance 20 meter in east direction. So we started from A. First we are going to point C, which is at 10 meter. Then we are going to point D, which is at 20 meter. And finally we are reaching at point B, which is again 10 meter. Okay, so our source is point A and our destination is point B. Okay, now for this question, if someone asks that what is distance and what is displacement, so can you please answer in this case?
Distance is traveling from point A through C, D, and then going to D.
Right.
And distance is shortest.
Very good.
20 meters.
So from here we can say our displacement is 20 meter east, because we have to be very specific about the directions also. And as far as distance is concerned, then distance is 40 meters. Right, because in that case we do not take care of directions. Right. Now in respect of that distance and displacement, there are two other parameters. One is speed, another is velocity. So please tell me what is speed and what is velocity?
So speed is a certain amount of distance traveled in a certain amount of time.
Right.
And and velocity is the same thing as speed, but I think also in a certain direction. Right. A certain acceleration.
Right. Please see. The only difference is if you take total distance upon time. Right. So in this case we get our speed. On the other hand, if we calculate total displacement upon time, then we get velocity. Right? So as displacement is a vector quantity, so definitely velocity will be a vector quantity also. So please see, if we start from point A at time t equals to 0 and we are reaching at point B at time t equals to 5 seconds. Right? So from this formula we can calculate a speed, that is 40 meter divided by 5, and we get 8 meter per second. Right? And if you calculate velocity, then it is 20 in east direction divided by 5, so we'll get 4 meter per second east. Right? But now the question is that can you guarantee that this body moved throughout the motion with this velocity only?
I'm sorry, I didn't get your question.
Question is, like if we are getting answer for speed is 8 meter per second. So can we conclude that this body was moving with constant speed 8 meter per second throughout the motion? Can we make this conclusion or not?
No.
Definitely we can't make that. Right? So if someone asks you to speed of this object at point P, anywhere in between the path, right? So we can't say that this speed is 8 meter per second. Right? Then we need to develop some technique so that we can calculate speed at this point also. Right? So please pay attention that whenever you have to calculate speed at any particular point, then speed is defined as v equals to dx over dt. Right? This particular term is called instantaneous speed. This is called instantaneous speed. Right? So from here we have to be very specific that if you are calculating total distance upon total time or total displacement upon total time, then actually we are calculating average speed. It is average speed and average velocity. But if you want to calculate speed or velocity at any particular point or at any particular time, then you have to find out speed or velocity using this formula. This formula represents rate of change. Okay? It is a mathematical term. It is called differentiation. Okay. So
I just want to know what the dx represents.
Yes. Look, it is a term which is very new to you because it is part of advanced mathematics. That mathematics stream student learn this topic, but as a student of physics, you also have to learn this topic of differentiation. It is called differentiation. So once you start the course, then in that course you will first you will get to know about differentiations. After that you can use that formula, right? For now, just keep in mind that it is notation of a mathematical process that is called differentiation, right?
Okay.
So by using this you can calculate instantaneous. And the second important point which you always need to keep in mind, that there are two versions of speed. First is average speed. In that case we calculate total distance upon total time. On the other hand, second one is instantaneous speed, where we calculate speed at any particular time instant. Right? Now please see. Now next factor is acceleration. So please tell me, what is acceleration? What do you understand by that?
So acceleration is, I guess, the average calculation of the change of speed over time or distance.
Yes. So please see, whenever you define acceleration, then you have to be very careful, right? Because acceleration is a vector quantity, right? Vector means direction is important. So in definition of acceleration, we can't use term speed, because speed is a scalar quantity. So acceleration is defined as the rate of change in velocity, that how velocity of object is changing. Again, we can calculate acceleration of a body in two different methods. First one is average acceleration. If you have to calculate the average acceleration, then you need to calculate change in velocity upon change in time. This delta represents change, right? And if you have to calculate instantaneous acceleration, like at any particular time or at any particular point, so we can use formula A equals to dV over dt. Again we are using this differentiation. Okay. So it is rate of change of velocity. Okay. Okay. Now let me just quickly tell you that because we can't avoid, although we always try to help NEET students and so that they can avoid use of differentiation, but you can't completely avoid this, right? So at some point you need to learn that how to differentiate. So please see, there is very simple formula. If you have to differentiate, so it is denoted by d by dx. right? And suppose if I am giving you a function that d by dx into x to power n. So there is very simple formula. Just take out n and reduce power of x by 1. That's all. Okay. Like if I am giving you an expression that d by dx into x cube. So here you can see n is equals to 3. So here we'll get 3x square. That's all.
Okay.
Right? Just take out the power and reduce the power by 1. You will get your answer. Anyway, now please see. So as we have three definitions for distance displacement, for speed and velocity, and for accelerations. Now we can develop some set of equations, right, for speed and velocities. And you already derived all these equations in grade 9th. Okay, I am not going to use integration method. I am just going to tell you by elementary method so that you can understand, and you must have done this sort of derivations in grade 9th also, right? So please keep in mind that every equation in physics comes with certain terms and conditions. So remembering equation is not important. You must know the conditions under that these equations are right. Okay, so let's make an assumption that suppose there is an object. This object is moving with some initial speed u at time t equals to 0. Now we are applying some acceleration on this object. Due to that, its velocity is changing and we are getting a new velocity v at a time t equals to t. During this process, object covers a distance s. So this is our fundamental assumption that if there is an object having initial velocity u at time t equals to 0 and we are providing an acceleration a, then in result of that, body is observing change in velocity to v, right? And during this process, it covers a distance s, right? So let's go by the definition of acceleration. The definition of acceleration is change in velocity upon time. So here you can see acceleration is denoted by a, final velocity is v and initial velocity is u. So change in velocity is v minus u. And we are dividing it by the time t. If you manipulate this equation, then you will get v minus u equals to 80. Right or not?
Yeah.
Okay. So if you arrange this, I hope now you must remember this one, that is v equals to u plus 80. This is first equation of motion. Right?
Okay.
On the other hand, there are two important concepts which you at this stage you just need to remember. Once you get advanced level, then you can easily understand that from where we have got these relations, right? But for now you just need to remember that area of a graph between velocity and time will give you displacement. Okay, so whenever we have a graph between velocity and time, and if you can calculate area of that graph, then you will get the displacement, right? So now what we need to do, we have to plot a graph for this given condition, what we considered here, right? So let's try to plot a graph. So here we are taking two axes. On x-axis we are taking time. On y-axis we are taking velocity. Now from in this diagram you can see when time is 0, then velocity of object is u, right? So let's mark a point. At this point velocity is u and time is 0. When time is t, this object having velocity v. So let's mark a point here. Okay. Now if you know 2 points are there, then you can connect them like this. So it is a graph between velocity and time. Now this concept is saying that if you want to calculate the displacement, then you have to calculate the area of graph. It means this region. Okay. So let's try to calculate area of this graph using simplest method. So what we can do, we can divide this graph in 2 parts. Right? Here you can see we are getting a rectangle and a right angle triangle. So can you please help me to calculate area of this graph?
So the rectangle will be the length into the breadth. So from the length of t up to u.
Right. So it is u into t. One side is u and another side is t. Now what would be the area for this rectangle?
Triangle, it's half.
Half into base length is t. And what would be this height? It is
u to v.
v minus u. Right?
Yeah.
So from here we are getting v minus u. Now you can please see. We know that v minus u is equals to a into tt. Right? So we can substitute in this equation. Right? So from here you will get s equals to ut plus half at square. Right? So it is our second equation. With the help of this, we can calculate the distance covered by object. Right. Now please see. If we try to calculate this area using any other method, so we may get a new equation. Please see. If you look carefully, then this diagram seems like a trapezium.
Yeah.
Right? So we can use formula of trapezium also. Do you know what is formula for area of trapezium?
I'm not aware.
Okay. Area of trapezium is 1 by 2 into sum of parallel sides. So you can see there are 2 parallel sides. One is u, another is v, right? Multiplied by distance between these 2 parallel sides. So you can see this distance is t. So here we are getting 1 by 2 u plus v into t. Right? Now if you want, then you can substitute from here that t is equals to v minus u upon a. Okay. So if you place here, in place of t, you are writing v minus u upon a. So you can see we are getting v plus u into v minus u, and in denominator we are getting 2a. So from here you will get 2as is equals to v square minus u square. So from here we'll get v square equals to u square equals to this equation. Okay, you must be aware about all 3 equations. Right. Okay, so look, let's go for problem solving because we have not much time left. Right. And if in between there is requirement of some concept, then I'll explain the concepts. Right. Okay, this is question number 1. and in this question this option is 0. Okay, so let's go through this question. It is saying a particle starts moving linearly at time t equals to 0 such that the velocity changes by equation v equals to t square minus t, where t is in second and v is in meter per second. Find the time interval for the particle retards. Okay, so because it is first question and you are not aware about differentiation, so let me do the basic steps. After that you try to find the answer for this question. Okay, so in this question I will check your reasoning part only. Please see, in this question expression for velocity is given, v equals to t square minus t. So by looking at this equation you can see here velocity is depending on time. Okay, now you have to find out time for which particle retards. So do you know what does it mean by retardation?
Deceleration. So it's slowing down.
Yes, it is negative acceleration, right. So it means from this velocity, first of all, we have to calculate expression for acceleration. Only then we can make some conclusion. So let me help you to find acceleration. After that, you try to get the answer. Now we know that acceleration is equals to dv by dt. Okay, so we have to differentiate this term, d by dt, and velocity is t square minus 2. So it is just like simple algebra. You just need to open the brackets. So from here we get d by dt into t square minus d by dt into t. Now you can see, as I told you that if you have to calculate some differentiation, then take out power outside and multiply, reduce the power by 1. So for first term we are getting 2 into t, and for second term we are getting 1. So it is our expression for acceleration. Now it's your turn. Please find the time interval in that this particle retards. As you told me that acceleration when body is slowing down, then we call it retardation, right? Now this question is asking for the condition that when this body is getting retarded. So acceleration should be less than 0, because the body goes slow down when you apply negative acceleration on it, right? So if we put a equals to negative, then you will get 2t minus 1 is less than 0. It means t is less than 1 by 2. And you know that time can never be negative. So if your time is between 0 to 1 by 2, then this body is going to retard. So option B will be right. Okay. Now I think still these questions are a bit difficult for you. So let's do some other questions, like question number 3. Please do. This question can be easily done. Just apply the concept that average speed is equals to total distance upon total time.
Is it B?
Yes, yes, yes. So how you got the answer? Please tell me. Your answer is right. Option D is correct.
So we have to add the two distances they gave together.
Right.
And then I assume the 5 is the time.
Okay, no, not like that. Please see. It is saying a car covers 2 by 5th of the total distance with the speed v1 and 3 by 5th of the total distance with speed v2. So you have to calculate the average distance, average speed. So let me explain this concept in detail so that you can get proper clarity about average speed. Please see. Suppose we have to cover a total distance x, right? Now this question is saying that in first part, that is 2 by 5 of this object is moving with the speed v1. And in second part, that is remaining portion 3 by 5x, of course, object is moving with the speed v2. So please see, whenever you have to get average speed, just stick to only one point, that is total distance upon total time. So to get average speed, anyhow we need to get value of these two. So please see, as we considered that this object has to cover a distance x, it means it is very clear that total distance is x. Now we have to calculate the total time. So let's assume that this object takes a time t1 to cover this part of distance and takes time t2 to cover this part of distance, right? So what we can do, we can calculate t1 is equals to distance is 2 by 5x upon speed, right? Because we know that time equals to distance upon speed. So from here we are getting 2x upon 5v1. In similar fashion we can calculate t2, that is 3 by 5x upon v2. So from here we'll get 3x upon 5v2. Now we have to calculate the total time. So total time would be t equals to t1 plus t2, right? So it is t1 plus t2. So t1 is 2x upon 5v1 and t2 is 3x upon 5v2. Now if you take LCM, then you will get 5v1 into v2, right? So in first term we have to multiply by v2, so we'll get 2v2 plus 3v1. It is our total time. Now we can substitute here, so I can write in a bracket like 2v2 into 3v1 and x is common, divided by 5v1 v2. So this x and x would get cancelled and this term will shift it to the numerator, and from here you will get 5v1 v2 upon 2v2 plus 3v1, right?
Yeah.
Okay. Now let me quickly write the formula and let me ask some questions directly based on those equations, right? And you try to answer these questions. We have three equations, that v equals to u plus at, where v is final velocity, u is initial velocity, a is acceleration and t is time. Next one is v square equals to u square plus twice a into s. And third one is s equals to ut plus half at square. Now the question is, an object starts with velocity 40 meter per second. When brake applied, comes to rest in 5 seconds. Find retardation. So how much retardation are we applying to make its velocity 0 so that it can come to rest in 5 seconds? Please calculate.
So
Yes.
do we use the first equation?
Yeah, sure. Please use and let me know the answer.
Is it 20 meters per second?
Okay, let's see. Please see. First of all, unit of acceleration is meter per second square because we use formula velocity upon time, right? Velocity is in meter per second, and if you divide by second, then its unit should be meter per second. Now please see, once you get questions like this, then first of all, note the data given in question as per the proper symbol. So this body start with 40 meter per second. So we can note u is equals to 40 meter per second. Now body is coming to rest. It means final velocity is 0. And for this process, it takes time 5 seconds. Now you have to calculate acceleration. So you can guess that we can use first equation, v equals to u plus 80. So v is 0, u is 40, we have to calculate a, and t is 5. So from here you will get a is equals to minus 40 upon 5, that is minus 8 meter per second square. So acceleration, or you can say retardation, is 8 meter per second square. Is it clear?
Okay. Yes.
Okay. Now next question is, a car started with its speed 10 meter per second and increases its speed by 20 meter per second during 10 meter distance. Find acceleration of car. So a car started with 10 meter per second and its speed changes to 20 meter per second in 10 seconds. So you have to calculate the acceleration of this car. 15 meter per second. Okay, let's check. Its initial speed is 10 meter per second, right? Final speed is 20 meter per second. Acceleration we have to calculate, and it covers a distance of 10 meter. So which equation we can use?
The second one.
Like s equals to ut plus half at square?
No, v square
Okay,
equals u square plus.
So we can use this equation, v square equals to u square plus twice as. So v square means 20 square, that is 400, right? And u square is 100, and it is 2 into 10 into s. So from here you are getting 15 meter per second square. Very good. So this answer is correct. Good. Now next question is, a car comes to rest after covering 40-meter distance when brake is applied and the retardation is 4 meter per second square. Find initial speed of car. Root 320. Root 320. Right? You are right. Answer would be root 320. Okay. Okay. Let me ask the last question. It is a bit tricky, so please pay attention. Suppose there are two cars, car A and car B. Okay. And they have to finish a race, which is the finish point is at a distance 100 meter. Okay. If car A moves with the acceleration 4 meter per second square, okay, and loses this race by 2 seconds. So find A is moving with the acceleration 4 seconds and losing this race by 2 seconds. So find acceleration of B. Okay, look, just wait for a second. Please tell me the procedures. How will you get this, solve this question? That's all. No need to get in calculation.
So I'm thinking we should use the v square equals v square plus 2as, that equation.
Okay.
And then calculate it for
Okay. Now please see. Actually, that equation is not going to work, because in this equation time is important, right? So what you will do, consider initial velocity of both the cars 0. Use equation s equals to ut plus half at square, right? So by using this equation, you can calculate time taken by car 1, right? Let's say, and that time will be less than 2 seconds. If you subtract 2 seconds, then you will get time for car B, right? And again, using same equation, you can calculate acceleration of car B, right? Okay. Anyway, so I think it is sufficient for today. We'll send you feedback of this session, right? That what is my assessment, and after that you will get a call from Testprepkart by tomorrow. Okay. For now, you can log out. Thank you.